Well, good evening, everyone. This is Gerald McKeegan. I'm up here at the Chabot Space and Science Center up in the Oakland Hills on Skyline Boulevard in the middle of the beautiful Redwood Regional Park. I was up here earlier today, and the poppies are all in bloom, so it's really beautiful up here right now. So we're going to do something a little different tonight. Normally at Chabot, every once a month, we do a program called The Sky Tonight. We do that in our planetarium. Unfortunately, we can't bring you up to our planetarium, so we're going to try to do a little bit of a planetarium show for you on Facebook. So the guy who writes most of the scripts for our planetarium show is Don Saito. Don has been a Chabot volunteer for more than 20 years. I've known him for 20 years. He's a great guy. Great sense of humor, and he's really good at doing narrations. So Don is going to present a short version of our Sky Tonight program. After he's done, I'm going to tell you a little about an upcoming event, and then we'll do some questions and answers. So bear with us here. Computers are not always the easiest things for us to use, but we'll try to make it all work here. There we go. And here we go with Don Saito and The Sky Tonight.
Howdy everybody. Just because current conditions are such that we can't meet inside our fabulous Zeiss planetarium at the Chabot Space and Science Center doesn't mean we can't go outside and look up at the real sky ourselves. This short presentation will help guide you to find several constellations, bright stars, and even a planet and a very pretty binocular-ready deep sky object. For the month of April, from about 9 to 11 p.m., we are well into the spring season of constellations, and it's these I'll be pointing out. By the way, if you weren't already aware, yes, the constellations have seasons. For example, you'll never see Pegasus, the flying horse, during the spring season, and likewise, you'll never see Leo the lion in the fall. As you probably already know, the Earth has 4 seasons: spring, summer, fall, and winter. Well, the constellations also have seasons, having to do with the Earth's orbital path around the Sun. That, and the fact that we can only see stars by looking away from the Sun at night, which changes our view of the stars throughout the year. Unfortunately, unless you're at a good dark sky site, most constellations will be somewhat hard to see fully. But most constellations have at least a few bright stars to help identify them, and the better your viewing location, the more you'll be able to see. A good first step to finding the constellations is done by knowing your compass directions. We can easily do this without a compass using a star grouping that almost everyone is familiar with, the Big Dipper. First, find the Dipper with its curving handle and bowl, which is high up in the sky at this time of the year. The 2 stars at the end of the bowl are called the pointers because if you take the distance between them and extend that distance out about 5 times, you'll come to a semi-bright star known as Polaris and otherwise known as the North Star. It's the only star in the entire sky that stays pretty much right where it is, so no matter what time of night it is or what month of the year it is, all you need to do is face it and you'll be facing due north, with east directly to your right, west directly to your left, and south directly behind you. Good, eh? All the other stars wheel around this point counterclockwise, making them appear to rise in the east and set in the west. This is of course an illusion caused by the Earth's spin, which gives the appearance that the stars are moving, when in fact it is the Earth that's moving. If you think of the Earth as a spinning top, and you extend Earth's North Pole straight up into the sky, it points almost directly at Polaris. I should also point out that the Big Dipper is not a constellation. It's only part of the constellation Ursa Major the Great Bear. To see him a bit more easily, let's turn from our northern-facing view to face the southern horizon, like so. The Big Dipper is what is called an asterism, which is defined as a familiar star grouping. Using Polaris, we found all the compass directions, but Polaris is also the end of the Little Dipper's handle, whose official name is Ursa Minor, the Little Bear, and our next constellation. It's a bit faint, but from Polaris, you might be able to trace its curving handle to its bowl. The two brighter stars at the end of the bowl are called the guardians because they seem to march around the North Star like protective sentries throughout the night. We use the pointers in the Big Dipper's bowl to find Polaris and the Little Dipper. Now, let's use the Big Dipper's curving handle to find our next constellation. Simply follow the arc of the Dipper's handle in a continuing arcing line to find the bright star Arcturus, which is the lap of Boötes the herdsman. In other words, follow the arc to Arcturus. The herdsman has a flat triangular cap, a large head, a triangular body that appears to be in a sitting position, his leg and foot, and he's smoking a pipe. A simple shepherd keeping watch over his flock. To find our next constellation, continue that arcing line from the Dipper's handle, go through Arcturus and Boötes, and speed on to the bright star Spica, which is the rump of Virgo the Virgin, located in the southeastern sky. Most of Virgo's stars are pretty faint, and her overall shape is pretty rough as an approximation of a woman lying down, but she has a head, one arm pointing up, a body, two legs, and of course her shiny rump star Spica. Virgo is our first zodiacal constellation this evening. As you might know, all the signs of the zodiac are constellations. What you may not realize, though, is that the zodiacal constellations appear to form a ring around our planet that when viewed from the ground appears to form a line in the sky going roughly from east to west. We call this line the ecliptic, and it is only along this line that the sun, moon, and planets move. This is why the zodiacal constellations were so significant to astrologers. Not that astronomy scientists believe in the pseudoscience of astrology, most don't. But astrologers were some of history's first astronomers, and for their early work we are in their debt. Since we found one zodiacal constellation, let us locate the others in their east to west lineup. To the right, or west, of Virgo is the regal constellation Leo the Lion. Leo is well formed with enough fairly bright stars that make him easy to see. He has a head, neck, body, legs, and tail. Leo's brightest star is Regulus, located in his front paw. I'll show you a neat trick to find a deep sky object using Regulus in just a bit. The next zodiacal constellation to the right of Leo is Cancer the Crab. Now, you will never see the crab because it's made up of really faint stars, but it can be done from a good dark sky sight. He's also a very simple constellation, made up of a kind of squashed rectangle with a couple of single arms coming out from his head to the left and right. But in his head is the deep sky object I've been talking about, called the Beehive Star Cluster. I'll get back to it in just a bit. Moving westward again, we come to our next zodiacal constellation, Gemini the Twins. This is another constellation made up of mostly faint stars, so you'll probably only see the bright heads of these two stick-figure brothers. Their head stars are also their names, Pollux on the left and Castor on the right. Here now is the trick for finding the deep sky object, the Beehive Star Cluster, that I mentioned earlier. Go back to the bright star Regulus in Leo, and draw an imaginary line from there over to Pollux head in Gemini. Just a tad to the right of center on that imaginary line, and a bit below, you'll find the beehive. Use binoculars to nail it down. It's really very pretty. Our last zodiacal constellation is Taurus the Bull. I won't describe him in detail because he's already begun to set below the western horizon, but I had to mention him because he's got this month's only visible planet, the very bright and pearly white Venus. Venus will get brighter and brighter through April and part of May before we lose it in its apparent day-by-day crawl towards the sun's glare. Leaving the ecliptic with its zodiacal constellations, our last constellation for the evening is Auriga the Charioteer. Almost directly above Venus in the west, the bright star Capella can be found, which is our favorite chariot driver's bright eye. It's just his head in profile, but he's got a triangular cap, a hooked nose, and his head with big manly chin. And that's it. There are other smaller or fainter constellations out there, which I encourage you to look for using a good book and maybe a pair of binoculars too. Speaking of good books, I cannot more highly recommend the book The Stars, A New Way to See Them, by the author H.A. Rey, who you may know as the same author who wrote the Curious George books. Rey was actually a scientist who wasn't satisfied with the way modern star charts were drawn. The astroscientists were not interested in the characters, objects, or stories behind the constellations, so for convenience, they just connected the brighter stars into weird geometric shapes, slapped on their Greek names, many of which would mean nothing to the common person, and left it at that. That's all fine and well for them, but for us regular folk, we're more interested in the fun stuff. If you really want to learn the constellations, get Ray's book, which we usually sell here at Chabot's Starry Night gift shop, or from Amazon.com for about $17. I'd also recommend getting a pair of binoculars before getting a telescope. Binoculars are cheaper and easier to use, and there are many wonderful deep sky objects that can actually be best seen with just a pair of binoculars that are noted in Ray's book. If you do want to get a telescope, research on the web how to make an informed purchase. Be warned, there are a lot of bad telescopes out there with cheap components and shaky, muddy, fuzzy views that will disappoint you every time. A good scope will inspire you and your children to a lifetime of deep space exploration and an appreciation of science and nature in general. If you're interested in getting into the hobby of astronomy, joining a local astronomy club can be most helpful. Chabot is partnered with the EAS, the East Bay Astronomical Society, which has many activities and resources you'll find essential to helping get started in this amazing and beautiful study of our natural universe. Thanks for watching this video. If you like this content, be sure to click the thumbs up button, subscribe to our channel, and hit the bell notification icon to find out when new content has been uploaded. This will really help our channel to grow, which is a good thing. And we shall see you in the future.
Okay, well, thank you, Don. That was great. So tonight's a pretty clear night here in the Bay Area, so a good night to go out and try to see if you can find some of the constellations that Don was talking about. In fact, because everybody is staying home, nobody's driving, so the air pollution in the Bay Area has actually gone down. So it turns out the sky is a little bit clearer right now than it normally would be. So great chance to get outside and check out the stars. And like Don mentioned in the video, if you pick up a nice astronomy book, that'll help you find those constellations. Next week, we're going to have a different presenter going to tell us a little bit about the folklore and the myths associated with all those constellations. So you want to make sure you check in with us for that. I'm sitting up here at Chabot. I'm actually in Chabot's Going the Distance exhibit. You see behind me here the Soyuz space capsule. This is an old-style Russian Soyuz space capsule. Over on the other side over here, you see the Mars yard for our little mini rover. This is all in our Going the Distance exhibit, which is one of several venues that we have up here at Chabot. So when the time comes for us to open Chabot up again and folks start visiting again, you want to be sure to check out Going the Distance along with all of our other exhibits. In addition to the events that, or the constellations that Don just described, I did want to call your attention to an event that's coming up that you may have heard about a little bit on the media. There is a large asteroid that is going to be passing by the Earth next Wednesday. It's going to be going by on the 29th, and there's been a lot of media attention about it because it's a very big asteroid. So I just wanted to tell you a little bit about that asteroid, if I can get it to, yeah, here we go. There we go, all right. Bear with me, I'm using a computer and I am not a computer's friend. My favorite saying is that I've never met a computer I didn't hate. All right, there we go. So the asteroid is called 52768. It doesn't have a name, it just has a number. We're kind of boring when it comes to naming asteroids. This is a big asteroid. It may be as much as 2 miles across. And it's going to pass the Earth next Wednesday, the 29th, at about 2:56 a.m. in the morning Pacific time. It's getting a lot of attention because it's so big, and if you've got a small telescope, you might be able to see it. Although on the night that it actually passes closest to the Earth, it's going to be over the southern hemisphere of the Earth, so you wouldn't really be able to see it from the Bay Area. During the next week or so, it's possible to see it with a small telescope, but you have to know right where to look. This is what we call a PHA, a potentially hazardous asteroid. It's an asteroid that's big and comes close to the Earth in its orbit. And this time around, it's actually not going to come that close. When it gets its closest, it's going to be about 16.3 times the distance between the Earth and the Moon. So that's actually pretty far away, 3.9 million miles. But because it's so large, it's getting all this attention, so you're probably going to see more about it in the press. Let's see if I can advance our slide here. There we go. Yeah, this is the orbit. The orbit type is called an Amor orbit. In an Amor orbit, the asteroid orbits in such a way that it's never actually crosses the Earth's orbit. So this asteroid originated in the main asteroid belt, which is between Mars and Jupiter, and it comes in and actually gets very close to the Earth's orbit, but it actually does not cross the orbit. So we call that an Amor type asteroid. It takes about 3.68 years to orbit around the sun. And you see a bunch of numbers there that mean a lot to us astronomers and probably doesn't mean much to you. This is some actual live video, actually not live video. These are some images that we shot Wednesday night of the asteroid as it was going by. I shot this with our 36-inch telescope called Nellie, which is the one we use for asteroid tracking. And we'll talk about that in 2 weeks. So anyway, that's an upcoming event, and you want to be sure to check it out if you get a chance, especially if you know somebody with a telescope and they know how to point it in the right direction. You can check out the asteroid. So what I wanted to do now is kind of open it up. You saw Don's video. Hopefully you learned a little bit about it. And what we'll do now is just kind of open it up on the chat board here and see if anybody has any questions about what kind of things to look at. Any questions about the constellations that Don talked about and so forth. So let's see what is coming up here. Lots of comments, people saying, okay, so where do you look for, question is, where do you look for the asteroid? Right now, it's in the southwestern part of the sky. I can't really describe it to you verbally. I would have to give you a set of coordinates and things. But if you go to a website such as Sky and Telescope, they actually have a sky chart that shows you its position every day, and you can certainly check that out. But there are also lots of other things to see in the sky and look at the constellations that Don talked about. He talked about those zodiacal constellations, that imaginary line we call the ecliptic. All the constellations along the ecliptic are what we call the zodiacal constellations. Let's see, I see a question. Will Don's video be available somewhere? Yes. This recording will be available on Chabot's Facebook page, so you will be able to go back and check it out again if you need to. Question, could the asteroid someday hit the Earth? Not in the near future. Although it does come close to the Earth, it does not cross the Earth's orbit. So for the time being, we're in no danger of this asteroid hitting us. but asteroid orbits are pretty unstable over time. Near-Earth asteroid orbits are pretty unstable, so there is a chance in the distant future, but probably not in our lifetime. Let's see, Mike Steckel says, do you think the upcoming Eta Aquarid meteor shower on May 5th will be visible in the Bay Area? Unfortunately, it will be near full moon, so while the shower may be visible, it's likely that the moonlight's going to wash it out. But, check it out on May 5th. Let's see. Another question down here. Which telescope do you recommend for a starter, a 7-year-old boy and his parents, not for millions of dollars? Well, actually, there's quite a few nice choices out there. One of the images that you saw in John's video is a telescope called a Dobsonian telescope. That sits on a low mount. It looks like a lazy Susan, and it's a long, dark-colored tube. That is a Dobsonian telescope. They come in different sizes. Prices range somewhere between $300 and $600, depending on the size you get. It's actually a real nice beginner telescope. It's not motorized or anything like that. It doesn't have any expensive tracking devices on it. It's just a nice large aperture telescope that lets you see some cool things like the rings of Saturn and craters on the moon and many of the dark sky objects that Don was talking about. So if you look up Dobsonian telescope, you'll see there are several different companies that sell those. For a beginner, I'd recommend getting a 6-inch one. And like I say, that'll run you somewhere around $350 to $400. Let's see, what else we got here? Jamie says she wishes we were still open. Yeah, me too. What is the magnitude of the near-Earth asteroid? Right now, it's at magnitude 10. Probably that doesn't mean a lot to most of you. Astronomers use a magnitude system, and this is true for all celestial objects, stars, planets, and so on. We use a magnitude system for indicating how bright the object appears to the naked eye. And a bright star in the night sky, in fact, the brightest star in the night sky is a little less than magnitude 0. Stars like Vega are magnitude 0. Most of the stars that you see from the Bay Area are magnitude 1, 2, or 3. The higher the number, the dimmer the star. And the difference between each magnitude is 2.5 times. So magnitude 1 star is 2.5 times brighter than a magnitude 2 star. So right now, the asteroid is about at magnitude 10. Question here. We've been reading about the story of Orion the Hunter. When will he be next visible? Actually, right after sunset, he's still very low in the western sky, but the best time to see him again will be late next fall, like in November. Orion is generally considered to be a wintertime constellation. Let's see, what else we got here? Question for the host. We saw a planet in the western sky. Yes, you did. That is the planet Venus. That's what Don was mentioning in his video. That bright object that you see in the western sky an hour after sunset is the planet Venus. Venus orbits the sun closer to the sun than the Earth, and as it goes around, it sometimes gets pretty close to the Earth, and it gets quite bright. And it shifts back and forth. Sometimes it's a morning star, and sometimes it's an evening star. Right now it is an evening star. So if you go outside about an hour after sunset, look off to the west, you'll see it real bright in the sky. And it'll be up there for the next month or so, but you'll notice that it gets lower and lower each night, and eventually it will get back into the sun, and then you'll have to wait a week or so, and then it'll be a morning star. see, there was a bright, large, bulbous, vaguely red object. Not sure if it was red. It was most likely what you saw was Venus, unless you were up real early in the morning. If you were up really early in the morning, it would have been Mars. Mars is one of the planets that is visible after midnight, like 4 o'clock in the morning. Let's see, I had a hard time understanding how to see Polaris. Is it always identifiable from the same part of the Big Dipper? Yes. The two stars that Don mentioned that are on the bowl of the Dipper, those are called the pointer stars. If you can see the Big Dipper, you can use the pointer stars to point at Polaris. They always point at Polaris, so anytime the Big Dipper is up, it's very easy to find Polaris because the pointer stars in the Big Dipper will point right to it. Take the distance between the two pointer stars, go out of the bowl about 5 times that distance, and they point right at Polaris. And Polaris is always up from the Bay Area. It's about 38 degrees above the northern horizon. It's always there, so you should be able to find it any time of the year when you have clear skies. Let's see. All right, I don't see any new questions coming up. Well, while we're waiting to see if there are any more questions coming up, a couple other things I want to mention. Chabot is closed right now, so Chabot's revenue is very limited right at the moment. So we're encouraging all of our Chabot members and all of our guests on our Facebook page to go to Chabot's website. It's Chabot Space, all one word, chabotspace.org, and go to our donation page. We welcome all donations, and we're at a time right now when we're really needing those donations to help us get through the coronavirus shutdown, and that way we'll be able to open up whenever after the shutdown is over and get right back into business and bring all our people back and let you come on back up here and see real planetarium shows. Let's see. Pamela S., what is your favorite constellation to see in the sky? Gosh, I would say probably Orion. Orion is one of the easiest constellations to see when it is up. Orion has more bright stars than any other constellation in the sky, and it's got those 3 stars that form the belt of Orion. Makes it very easy to identify. And telescopically, there's some interesting things in Orion. Below Orion's belt is a fainter string of stars called the Sword of Orion, and there's this beautiful nebula that's in the Sword of Orion. That's actually where new stars are being born. So Orion is a pretty interesting constellation to look at. But there's quite a few others up there. Cancer, Don mentioned. A little later on this spring and into the summer, you're going to see, let's see, we'll have Aquila will be up. Lyra, we just had the Lyrid meteor shower here a few days ago. Those originate out of the constellation Lyra. The Swan will be up. Those are all in constellations and fairly easy to see even from the Bay Area. So as we get summer, you'll look for those 3 constellations: the Swan, Aquila the Eagle, Lyra, which is a harp, and all of those will help you to learn your way around the sky. And John's going to do another presentation. He's going to do another Sky Tonight presentation in about a month. So he'll probably talk about those constellations when the time comes. Let's see. When are we going to show the moon in the telescope? Well, we're talking about how to do that. Right now, the moon is just a little thin sliver in the western sky, but perhaps later on when we get maybe a waxing gibbous moon, we'll try to put a camera on the telescope and let you see what that looks like. Let's see, Noah, who is age 6, He asks, how are asteroids tracked to make sure they don't get too close to the Earth? Well, Noah, that's a good question. The technique we use is pointing a telescope where we think the asteroids are. We take multiple pictures. But I'll tell you what, if you tune in 2 weeks, I'm actually going to show you in detail how we do that. I'll show you the telescope we use to do it, and I will show you the actual process that we use. And it's quite interesting. I'm going to try to avoid throwing a lot of math or anything, so it should be pretty interesting for you to see, and you'll get a really good idea how we do it. I'll actually show you some images with asteroids in it, and you'll try to identify them and find them, and then I'll show you where the asteroid is, and you'll see how the tracking process is done. Let's see. Yeah, unfortunately, the Big Dipper's not always high enough. Don Saito is chiming in here. Don is the narrator, and so he's pointing out that when the Big Dipper is not up, there's another constellation called Cassiopeia, the Big W. And there are a couple of stars in Cassiopeia that can be used also to find Polaris. Cassiopeia also has an associated constellation called Cepheus, and there are some stars in Cepheus that can be used as well to find the Polaris, the North Star. Okay, let's see. Here's a good question. Jamie has asked, is Betelgeuse still getting dimmer? No, actually Betelgeuse has brightened again. So for those of you who don't know, there was a period of time here a few months ago when the bright star Betelgeuse, which is in the constellation Orion, Betelgeuse had suddenly started to dim, and astronomers were very curious about what's going on. We think Betelgeuse at some time in the next 100,000 years is going to explode as a supernova, and so when all of a sudden it started dimming, it got everybody's attention. It got dimmer and dimmer. Eventually we figured out that the reason it was dimmer is because it had puffed off a bunch of dust, and the dust had surrounded the star and caused it to appear dimmer. But that dust is now dissipating, and Betelgeuse is once again almost back up to its normal brightness again. So I guess we're going to have to wait for another 100,000 years before Betelgeuse explodes. Let's see, what else we got here? Does the Big Dipper look the same everywhere you can see it, or does it always point to Polaris? Yes, the pointers in the Big Dipper always point to Polaris, and if you're anywhere on the Earth where you can see the Big Dipper, it will always look the same. However, if you leave the Earth and you go out in space far enough, you'll discover that the Big Dipper no longer looks the same. From our perspective here on Earth, the stars all look like they're the same distance away, as if they are pinpoints of light on a celestial sphere. But in reality, the distance to those stars is different. So if you get far enough out into space, you actually see that the arrangement of the stars is not quite the same when you see it at different angles. Some of the stars are closer, some of them are quite far away. When Chabot opens again, if you go up to our new observatory deck, you will see an exhibit that actually illustrates the fact. It actually shows the stars in the Big Dipper as you would see them from here on Earth, and then you can actually walk around and see how they are actually arranged, and you'll see that when you look at it from a different angle out in space, it looks very different. All right. Would you tell us about some of your favorite unusual asteroids that pass Earth with at least some regularity? Well, I don't want to get into asteroids too much tonight because I don't want to spoil my program for 2 weeks from now. There are actually quite a few asteroids that pass the Earth. Most of them don't pass the Earth regularly because the orbital period of an asteroid is not the same as the orbital period of the Earth. So most asteroids do not go by the Earth on a regular basis. They go by intermittently. But there are so many near-Earth asteroids out there that we're always seeing asteroids pass by us. In fact, I was looking at some statistics this morning. Since the first of this year, 31 near-Earth asteroids have passed closer to the Earth than the Moon. But they're all small asteroids, and they all pass by us safely, so you didn't hear very much about them. But the reality is the Earth orbits the Sun in a shooting gallery, and there's asteroids whizzing by us all the time. What is the best website to see real space images? Well, one place you can go is to the Hubble Space Telescope website. The I think it's called the Space Science Institute. The Space Telescope Institute. And they actually have quite a collection of Hubble images of space. Hubble is very high resolution cameras. They do quite a bit with the colors to make it or the images. And there's some pretty spectacular images on Hubble's space. Another site is called the Astronomy Image of the Day, or Astronomy Photo of the Day. It's called APOD, and amateur astronomers submit their own images, and you'll find that amateur astronomers are pretty darn good at doing astroimaging. Let's see. What we got here? Do you know what time Betelgeuse will explode? Well, the best we can say is that it's going to explode sometime in the next 100,000 years. It might explode next week, it might explode next year, or it could be 1,000, 10,000 years. We're not sure. Astronomers are watching it. The problem is when a star like Betelgeuse gets near the end of its life, it starts doing some weird things, and you can tell it's getting close, but you don't know exactly when it's going to happen. Can we see any constellation tonight with the eyes? Yes, you can. The ones that Don mentioned in his program, all of those are visible constellations in the night sky. I'm going to excuse myself for a minute here. I got a cough. Okay, hopefully you didn't hear that. I do more talking on these programs than I do the rest of the week, so it's kind of rough on my voice a little bit. Moon moving slowly away from the Earth. Yes, the moon moves away from the Earth about 3 centimeters per year. So that's a little over about 1.25 inches, 1.5 inches per year. And the reason for that is the tidal interaction between the moon and the Earth. The moon's gravity is pulling on the Earth, the Earth's gravity is pulling on the moon. As the Earth rotates, its gravitational pull is slightly offset to the line between the Earth and the moon. That causes a slight acceleration of the moon, and that causes the moon to slowly drift away from the Earth. But it takes a long time for it to move very far. Like I said, it's about 1.5 inches a year, so it'll be around for a while. What is the speed of the asteroid right now? I assume you're talking about the one that's going to pass real close to the Earth next week. And it's actually zipping along pretty fast, about 30 kilometers a second. Excuse me. Do we have the ability to destroy an asteroid? Yeah, I'll talk about that a little bit more next time when I do my presentation on asteroids. We have some techniques for deflecting them. We don't necessarily want to destroy them because that could actually make things worse. Let's see what else. What will happen with when Betelgeuse explodes? Betelgeuse is a massive star, so it explodes in a supernova. And that means initially the interior of the star collapses, and then the star literally blows itself apart. Most of the what remains of the star will be blown out into space as a variety of different elements and dust and gases. But in addition, the remainder of the star will collapse down, and depending on its mass, it will either collapse down and become what's called a neutron star, or potentially it would collapse down and become a black hole. So that's one of the reasons why astronomers are so interested in Betelgeuse, is because we'd like to see what actually happens during a supernova explosion. Fortunately, it's far enough away. The latest figure I've seen for Betelgeuse is about 720 light years away. So that means even when it explodes, it's not going to be a problem for the Earth. We'll see it. In fact, it'll be bright enough for us to see in the daytime, but it's not going to cause us any problems. All right, let's see what else. Yeah. Another question about Polaris. Can you find it in the southern hemisphere? No, you cannot. Because of the location of Polaris, if you're south of the equator, you cannot see it. And furthermore, people living in the southern hemisphere don't have a south star. So it's only those of us living in the northern star who can see Polaris and can use it for navigation. Yeah. Yeah, Leonard Tramiel, he's one of our telescope operators up here at Chabot. He's also a very experienced astronomer, and he's just emphasizing the fact that we will be able to see Betelgeuse when it explodes. We'll be able to see it in the daytime. Is it big enough to become a black hole or a neutron star? Good question. We will find out when it explodes. We're not sure just yet which it will become, but when it happens, we will see. Patty asks, when's the next asteroid shower? Well, actually, you don't want an asteroid shower, but you do want meteor showers. Meteor showers are when very small objects, things the size of pebbles or grains of sand, left behind by comets, enter our atmosphere, and we see them as a meteor shower. We just had one this past week, the Lyrid meteor shower. Remnants of a comet that were around the sun. As the comet gets close to the sun, the ice on the comet sublimates. There's all kinds of rocks and pebbles and sand embedded in the ice. When the ice sublimates, that material is released. It becomes part of the tail of the comet. And if the comet is in the right orbit, those particles can actually cross the Earth's orbit. And when the Earth passes through that stream of particles, we see it as a meteor shower. That actually happens several times each year. The next big meteor shower is going to be in August. That's the Perseid meteor shower. It's around August 12th or August 13th. And then there's another big meteor shower in December called the Geminids. There are a few other lesser meteor showers between now and then, but the two that are really the spectacular meteor showers are the Perseids in August and the Geminids in December. Let's see here. I see that Rick Taft posted the link for the Hubble Space Telescope images. Thank you, Rick. Stars in the nebula in Orion being produced each month. Well, they're not being produced monthly. It takes actually hundreds of thousands of years to create a star, and there are literally hundreds of them within the Orion Nebula that are young stars in various stages. When we look at it through the telescope, there are 4 bright stars that we can see. We call them the trapezium stars, and they are young, very massive stars. Don't last very long. Massive stars actually have short lives, and low mass stars have long lives. So the stars in the trapezium are very hot, young stars. But most of the stars in the Orion Nebula, actually you can't see very well because they're still embedded within the cloud. Nebula means cloud, and when we look at it through the telescope, you'll see that the Orion Nebula is just a big, huge cloud out in space. And most of the young stars that are forming within the cloud are still embedded within the cloud, so we can't see them. But we do see a few of the stars that are beginning to emerge. But again, the process of star formation can take hundreds of thousands or even millions of years. So it's not a fast monthly process. It's a very long process. Let's see. Christina says, I think I see Venus at 3 a.m. from Marin looking back over Angel Island. Actually, what you're seeing is probably either the planet Jupiter, most likely the planet Jupiter. At 3 a.m., Venus has already set, but the planet Jupiter will be up in the eastern sky along with Mars and Saturn. So in the early morning, 3:30 a.m., it's going to be Mars, Saturn, and Jupiter that you'll be seeing, not Venus. Let's see here. How long will it take for the moon's imminent departure? Since it's moving away from us, how long will it take? Actually, it won't leave us. As it gets farther away from us, the tidal forces between the Earth and the moon grow less and less. And eventually the moon will reach a very stable orbit much farther away from us, and that will be literally billions of years from now. So never fear, it'll be there for your lifetime and many other lifetimes. How many stars do we know in the universe? I once heard that the number of stars in the universe is greater than the number of grains of sand on all the beaches of the entire Earth. And that's probably a low estimate. So we don't really know how many stars are out there in the universe. We just know that there is a lot. If you happen to go to the Hubble page, there's an image there, and there's actually a couple of them now, called the Deep Field images. And the deep field is an image that shows nothing but galaxies. Just it's image taken looking at a very small part of the sky, and even in that small part of the sky, there are thousands of galaxies. And if you think about those thousands of galaxies, each having 100 million stars or more, you get some idea. There are a lot of stars out there, and that's only in one little part of the sky, about the size of a postage stamp, arm's length. And it's the same in every direction that you look. So the number of stars is probably almost countless. Let's see. Will the sun become a red giant? Yes. Stick around. In about 4 or 5 billion years, the sun will become a red giant. It will swell up. It will be so large it will swallow up the planets Mercury and Venus and possibly the Earth. We're still not sure about that. But even if it doesn't swallow the Earth, it's going to become so big and so close to the Earth that the Earth will be fried. Let's see, what else we have? Are new constellations being identified as new stars are being born? Well, again, the star forming process is a very slow process. So in the typical lifetime, or even in the lifetime of the whole human race, there haven't been a lot of new stars that have appeared in the night sky. The constellations right now, there are 88 official constellations in the night sky, and it's going to be that way for probably a few hundred years. It's possible over long periods of time that a few new stars will show up. Most likely they will be identified as being part of existing constellations rather than forming new constellations. Someone notes here that the sun will eventually become, after it sheds its outer layers, it will become a planetary nebula. That is true. When the sun reaches the end of its life, during its red giant phase, it will shed its outer layers of gas. That will go on for a couple 100,000 years. Eventually, what's left of the star will collapse and become a white dwarf. And the white dwarf will be surrounded by all that gas that was expelled by the planet, or by the sun, before it collapsed. And that gas will be what we call a planetary nebula. And the white dwarf will emit a lot of ultraviolet radiation, which will actually cause the gas in the nebula to glow. Question, what is the best time to see the planets and stars? Well, the stars, anytime it's a clear night, and especially if you can get away from the city lights, the stars are out there. For planets, it depends on the time of the year, on which planets are up. Right now, Venus is up. Later on in the summer, Mars, Jupiter, and Saturn all will be up. All right, let's see what else we got here. I got another cough coming on, so bear with me here just a second. Take a cough drop before I do this. Let's see, what else we got here? Leonard, I don't think you typed enough zeros in your answer to the number of stars. There's probably a few more that we need. Some discussion here about the Space Launch System. We'll launch the Orion capsule. That's years down the road, but that will be happening. What else we have here? What is the biggest asteroid that hit the Earth that we know of? Probably the answer is the one that took out the dinosaur. That's the biggest one that we are fairly certain about. We think that one was about 6 miles across, and that was 66 million years ago. However, there have been many other impacts on the Earth. The Earth is not immune. We do get hit by asteroids periodically. There's evidence of other larger impacts, but most impact craters on Earth, because of weather and the oceans and life and animal life, they erode away pretty quickly. So finding craters on the Earth is pretty hard. But the one we're sure about is the one 66 million years ago, and that was 6 miles. That's unusually large for a near-Earth asteroid. All right, what do we got here? A tablespoon of honey. Yes, thanks for the advice. Unfortunately, I don't have any honey here with me, so when I get what about the James Webb Space Telescope? Yes, the James Webb Space Telescope is sort of the next big space telescope that's coming up. It's a much larger telescope than the Hubble Space Telescope. James Webb Telescope is actually going to be tuned primarily to infrared light rather than visible light. It will be able to see some in the visible spectrum, but it's designed to view in the infrared part of the spectrum. And that will launch hopefully next year. So stay tuned. Looks like our time is about to run out here, so I just want to invite you once more to go to the Chabot website, click on the donation link, and please help us out any way you can. We really appreciate it. And once again, we'll be doing this again next Friday. Doug Olson will be doing a program on the myths and folklore associated with the constellations. And then I'll be back again in 2 weeks introducing you to our newest and biggest telescope, Nellie, and tell you a little bit about how we use Nellie to search for and track near-Earth asteroids. Okay, well, I think we're about time to wind it up here. Thanks for your attention, and we'll see you next time.